Hello everyone. This week's video lecture is about the relationship between confidence interval and testing. Okay, we'll learn about the confidence interval in the previous chapter 6, and the hypothesis testing was covered in chapter 7. Okay, in the hypothesis testing, we construct the hypothesis, that is null hypothesis H0, and alternative hypothesis, and that is HA. Okay, and determine the rejection or not rejection of H0 by calculating the p-value using the test statistic. Okay, in this lecture I will introduce how to interpret this using the confidence interval. Hypothesis testing is a statistical procedure used to make inference or decision about population parameter theta we are interested in, and based on our sample data. Okay, the procedure is as follow. Step 1 is the process of formulating hypothesis. We can set the null hypothesis, that is the parameter theta equal a specific value theta 0, and alternative hypothesis, which can be a two-side the test indicating a hazard difference, or one side test indicating that theta less than theta 0 or theta greater than theta 0. Step 2 involves setting the significance level alpha. The alpha is a criterion for reject H0. Okay, it is commonly set to 0.05 or 0.01. In step 3, we calculate the test statistic under H0. That is, under H0, we can draw the distribution of estimator. Zero or that is H0 equal like this. And given the sample data, that is there using the estimator set ahead, we can calculate the test statistic. Okay, so we can calculate the p-value in the two-side test. Okay, in the step 4, p-value. Okay, and we draw our conclusion. Okay, let's look at the example 1. Example 1 is that was covered in chapter 7. A pharmaceutical company developed a diet drug. Okay, the company claimed that the average of 4.5 kilogram is reduced if the diet drug is taken steadily for 2 weeks. Okay, after taking the drug for 2 weeks, for 10 buyers, it means the sample size small n, their average weight decreased by 4.2 kilogram. That is the x bar. Assuming that the weight loss set random variable x follow normal distribution with sigma equals 3 kilogram. That is x follow normal mu comma the variance equal 9. Okay, in this problem, the pharmaceutical company claimed that their diet drug has an average weight loss effect 4.5 kilogram. Okay, therefore we can formulate the hypothesis as follows. In step 2, the significance level alpha equals 0.05. Okay, and in step 3, assuming the null hypothesis is true, that is under AC0, we can find that the x follow normal 9. Okay, therefore the distribution of sample mean x bar follow also normal 9. Okay, that is x bar minus follow standard normal distribution is like this. Okay, the given sample mean, the x bar equal 4.2, so the test statistic is like this. Okay, so we can get there minus 0.3162. Okay, therefore the direction of reject null hypothesis is that. Okay, so the p-value based on the statistic this area. Okay, so the p-value is 0.7519. So we cannot reject AC0 because the p-value greater than 0.05. The 100 multiply 1 minus alpha percent confidence interval for the parameter theta, which was covered in chapter 6 as follow. it is a range of values constructed based on sample statistic that is believed to contain the true population parameter theta with 100 multiply 1 minus alpha percent confidence level. Okay, that is so the confidence interval has lower bound estimator and upper bound estimator. That is, lower bound estimator is the theta hat minus their critical value. Value is depending on the alpha multiply the standard error of theta. Okay, and upper bound is theta plus the critical value multiply the standard error theta. For example, if theta represent the population mean mu and the confidence level is 95%, that is alpha equals 0.05, we can obtain the following, the confidence level. Okay, that is under some assumption there that is x follow square, then x also follow square, so this probability equal 1 minus alpha. It means the confidence level. Okay. So the standard the distribution is C alpha. So this 2 point means the critical value. Can like this. So note is Mr. critical value Okay, so this This means the lower bound estimator. This means the upper bound estimator under the the confidence level or minus alpha. Okay. Level. If we assume the population parameter mu equal mu 0, it means the age is 0. We can draw the distribution. And the alpha we set as a tail probability. Tail probability become the reject region. Okay. And equal mu 0 means the specific value in their x is 0. Okay. Therefore, if the confidence interval the calculated from those sample data include the mu 0, we cannot reject AC0. Okay. Conversely, it is the fall into the reject region, the confidence interval, that is it is not include the mu 0. So in this case, the reject is 0. Okay, it equal there. In example 1, we can calculate the 95% confidence interval for mu. Okay, the formula is as follow. So the confidence level is like this. The and your critical value is 1.96. So the lower bound estimate is 2.34. Upper bound estimate is plus. Okay, it's like this. If we assume the mu equal the 4.5 kilogram. Okay, they'll like this. Okay. And in the sample data, we can get the x bar equal 4.2 kilogram, and the corresponding the confidence interval like this. Okay, that is the interval like this. So the confidence interval include the mu zero, that is 4.5 kilogram. Okay, therefore, based on this result, we cannot reject the null hypothesis as 0. The result interval the result equal in the hypothesis testing using the significance level of the 0.05, that is 5%. Okay. In other words, the confidence interval with a confidence level alpha, the alpha means the significance level for the rejecting the null hypothesis in the testing part. Okay, so this means the confidence level, and this alpha is the error, is the significance level in the testing part. In this case, let's set x bar equal 0.2 and the significance level alpha 0.01%. Okay. So step 1, the hypothesis is as follow. Okay. Step 2, the significance level equal 0.01. In the step 3, the under AC0 the x bar minus 4.5 follow normal standard normal distribution is like this. Okay, based on the given sample mean, the 1.2, so the statistic 0 equal 1.2 minus body equal, so minus 3.48. Therefore the p-value is the corresponding to this value. Okay, this is the probability. In step 4, the p-value is the probability of the z minus 3.48 multiply 2. So this probability equal 0.0003. So the p-value equal 0.0006, which is less than the alpha 0.01. So we can reject the H0. You know, the under H0, the distribution of the standard digit of the x bar like this. In the distribution, we set the critical value minus small g, okay. This value is minus 2.58. So we can find that this region is called the reject region. Reject region. Okay. For H0. H0. Okay. So the statistical value minus 3.248 falls into the reject region. So we can reject H0. The corresponding confidence interval, that is 100 multiply 1 minus alpha percent, confidence interval equal apply inner alpha is 0.01, so 99% confidence interval. It is the low bound estimate x bar minus so x bar is 1.2 minus, this means 2.58 multiply 10. Okay, so minus 1.248. Okay, and upper bound estimate is x bar plus the critical value equal 3.648. Okay, inner, so the 99% confidence interval is okay. under AC0, the distribution is like this, and the confidence interval is like this. That is, the interval is not contain the 4.5 kilogram. Okay, so we can find that the AC0 is rejected. The result is equal to the hypothesis testing.